let us take the topic called that is types of reactions. Types of reactions. Basically, the reactions are three types: addition, elimination, substitution. But the two more reactions like rearrangements and the cycloadditions also takes place. So here first addition, second type elimination, third type substitution, fourth type rearrangement, fifth type cycloadditions. In the first type, addition means it is two groups we are adding. So therefore, we represent this reaction as a plus sign plus. An example, if ethylene is taken, treated with the HCl, for example, H is added one side and the Cl is added one side. So the A plus B will become C. So the molecule CH2 plus 1 add hydrogen CH3. This Cl is added to the other carbon, so you will get CH2 with Cl. So one side H, one side Cl added. Addition means putting together. So this ethylene and HCl join, you get single product. This type of reaction is referred as addition reaction. Okay. So A and B is brought together to give the single product. This is the simple feature to represent this reaction, addition reaction. In the elimination, it is exactly reverse. So from one side we are removing the hydrogen, from the other side we are removing the Cl. So HCl is removed as a HCl, so the molecule becomes into ethylene back. So what is removed is HCl. We should write HCl here, but as I said, ethylene HCl together will immediately join, you will get that one. That means the added product is more stable. So this compound is shown to be more stable. You can understand little here. This compound is said to be unsaturated. Unsaturated means what? The carbon has a generally 4 valency, tetravalency. If these 4 valencies are with 4 atoms, these atoms can be all hydrogen, all carbon, or mixed carbons and hydrogen. But here you see the carbon, it's making 4 bonds, but the atoms are 2 hydrogens and 1 carbon only. 3 atoms, 4 bonds. So therefore, somehow it is adjusting. The type of adjustment of a carbon, 2 carbons are there. With this carbon, 1 sigma bond, 1 more pi bond, isn't it? So 3 atoms are there, but 4 bonds it is making. It is adjusting, isn't it? The type of adjustment of this carbon is said to be unsaturation. If this is also 1 more hydrogen or carbon, that is called saturation. So it accepts 1 hydrogen, makes the 4 bonds with 4 elements. See, 3 hydrogen, 1 carbon. So that is called saturation. Always unsaturation leads to give the saturation. That is what the universal phenomena. Unsaturation leads to saturation. So this is a universally accepted reaction. Unsaturated readily becomes into saturated. In such spontaneous reactions, not necessary to heat it or put some catalyst or some external forces are not necessary. You just take this gas and that gas, just wait some time, you will get the ethyl chloride. So that is a ready reaction. Whereas from saturated, unsaturation means some drastic condition, just like evaporation of water is a spontaneous process, but if you heat it, it becomes ready, like that here. So from here, this to that, the reaction may be, for some extent it is spontaneous, but to get the reaction, some specific condition is required. What you are removing, the HCl is an acid. So if you put a strong base like KOH dissolved in the alcohol and heat for some time, see all these odd conditions we are putting, this base will knock away this HCl to form the KCl and water. Then the reaction takes place. Otherwise, ethyl chloride readily, ethylene will not be formed. It is a just like water from upper side to lower side spontaneously comes. Somebody is helping, that is gravitational force. From here to there, water to go readily will not go, but if you apply pump or evaporate water and go and there raining, something, some other forces like wind force or some force which should be allowed, then only the reaction takes place. Like that, ethyl chloride to ethylene is not a ready reaction. This is saturation becoming unsaturation. So they are not a universally immediately acceptable reactions, but under some specific or drastic conditions, reaction. Don't write HCl here, immediately comes back. So HCl is turns into KCl and water, then the reaction will not come. So the gone product will take one shelf and there will settle for some time. If again some condition, if it is created, it may come back. But right now, ethylene and KCl and water can sustain in one flask, they won't come back. What is substitution? So the elimination may be given as a symbol minus and minus. Both the groups are removed. Here both the groups are added, so plus plus symbol. Elimination is minus one. In the substitution, you can say plus minus or minus plus. That is add and remove or remove and add, right? So either way it is called substitution. An example, if you take a methane. Methane has 4 hydrogens. As I said, it is a stable one because it is a saturated one. But under some conditions, when I add chlorine gas and use UV light or heat it around 250 degrees centigrade, one chlorine entering and replacing the hydrogen, that hydrogen goes with Cl, forms HCl. One Cl comes in the place of the H. It is replacement reaction. It is also technically we are calling as a substitution reaction. One Cl, H and Cl goes out as a HCl. So this type of one coming in to the molecule, one is going out also simultaneously or one after the one. So the reaction leads to give a new group containing, but still it is saturated. A saturated gives saturated, but one group is going out and in the same place a new group is coming out. So either plus followed mechanism, plus followed by minus, or minus followed by plus, or simultaneously this going, that coming. All the mechanisms are there in practice, but somehow one group is going in the same place, new group is coming. So that mechanism is said to be a substitution. These three are more obviously in the organic chemistry you find: elimination, substitution and addition. And rearrangement is another type of reaction. If I have a ABCD molecule, this molecule, the course, that is the, I rearrange these groups into ADBC, let us say. This type of reactions are said to be the rearranging the groups internally and getting the same type of the molecular formula will be same. An example is the ammonium cyanate. On heating, ammonium cyanate on heating gives a urea molecule. The order of the molecules in the first case C, there is a nitrogen, 4 hydrogen, C and O. Same are there, molecular formula is same, but structurally this is different, that is different. Ammonium cyanate on giving urea molecule is identified, biologically it is possible, and it is chemically somebody identified it is taking place, and where the vital theory was disproved, and ammonia, that is the urea, is a biological product in fact created outside the system of a cell. So he proved that there is no necessity for the biological system help, and the arrangement is going on changing. So therefore such type of reactions are specially classed as a rearrangement. We have further classification, which element is rearranging, which group is from where to where it is traveling, migration, terminus and origin and all that. We have further classification, let us leave it now. Cycloaddition is another type of reaction where a molecule containing 2 pi bonds like this, when it is added with another pi bond containing molecule, hydrogens are there, and it undergoes a cyclically, this 4 plus 2, 6 carbons will join and make a ring type of compounds are formed. Cyclically, they are joining. This adds here, this end adds here, this end adds here. A ring is formed. However, one double bond restores. The compound is a cyclohexene is formed. This type of reactions have lot of stereochemistry is involved, and they are not like the heat or the catalyzed reactions. They have a different types of the approach totally. They are later studied as a Diels-Alder reaction, and they are later further study shows they are all the pericyclic reactions come under the pericyclic reactions. But right now just two pieces are joined and a ring is formed. So such reactions we recognize as a cycloaddition. So there are 5 types of reactions basically. Now each reaction, addition and substitution especially, are further classified into three types. Addition is classified into addition, a new group is coming, isn't it? So first coming, second coming. So let us leave the second coming, but first coming, is it electrophile coming, nucleophile coming, free radical coming? So addition further classified into electrophilic addition reaction, nucleophile. First adding, out of the two, one adds first, not both simultaneously. So which one first adds, electrophile adds or nucleophile adds? Based on that, the addition is further classified into 3 types. Even substitution also, in the substitution also, one is coming and one is going. Outgoing I am not interested, but what is incoming? Based on incoming, here both are coming, therefore based on first coming the addition is classified. Based on which is coming, outgoing I am not interested, what is coming, I classify substitution into 3 types: electrophilic substitution, nucleophilic substitution, periodical substitution. In the elimination, nothing is incoming, only outgoing. So based on incoming we classify, therefore elimination is not classified like electrophilic elimination. Like that we don't have any classification, but addition is further classified. Addition is classified into the electrophilic addition reaction, nucleophilic addition reaction, and radical or a free radical addition reaction. Just you can abbreviate like this in a short way. Similarly, substitution can be classified a electrophilic substitution reaction, nucleophilic substitution reaction, and radical or free radical substitution reaction. So all these 3 plus 3, 6 reactions we are going to see in detail, with one elimination reaction in detail. So these 7 reactions we are going to see in detail later. So first let us take electrophilic addition reaction, or you can also write which compounds undergo which type of reaction. Here itself we can make a small chart. Electrophilic addition is observed in the alkenes and alkynes. Both alkenes and alkynes undergo this as a characteristic reaction. Nucleophilic additions are seen in the aldehydes and ketones. Aldehydes and ketones. Both these compounds, somebody can ask direct question, what is the characteristic reaction of aldehydes? It is addition, specifically nucleophile started addition. In the free radical addition, again alkenes and alkynes undergo this reaction, but in presence of radicals, in presence of free radicals. Whenever free radicals are there as a catalyst, this reaction takes place. Similarly, substitution, electrophilic substitution, benzene and aromatic compounds undergo this reaction. Benzene and aromatic compounds is the characteristic reaction. Nucleophilic substitution, alkyl halides undergo this reaction. Alkyl halides undergo this reaction, RX. Free radical substitution, alkanes undergo this reaction. Almost most of the chapters are covered now. Elimination reaction is not classified into the further. Elimination is not classified like this. Addition is based on first attacking species is the criteria. Here one coming, one going, no first and second coming, only coming. Incoming group is the criteria. Incoming group, based on the incoming group we are classified. Elimination, no incoming or no first attacking, only outgoing only. Therefore, it is not classified into this one. However, substitution, specifically nucleophilic substitution reaction, has a further classification into the three types. Substitution nucleophilic 1 molecular and substitution nucleophilic 2 molecular, that is bimolecular. Unimolecular nucleophilic substitution, bimolecular nucleophilic substitution, substitution nucleophilic intramolecular. I stands for the intramolecular. Like that, even elimination is also, this is based on the kinetics. This is based on the kinetic approach we are classifying. This is also kinetically we are classifying into the elimination with 2 molecules, elimination with 1 molecule, that is bimolecular, unimolecular, and elimination with unimolecular E1CB. This is a elimination unimolecular with conjugate base. This type of classification also we have. Now we are going to see this 3 plus 3, 6 plus 1, 7. In this 3 types, in this particular nucleophilic substitution, again 3 types we are going to see. All these reactions are fundamental reactions of, in each chapter you have this one fundamental reaction. Every reaction leads to, that is needs a thorough understanding. If one electrophilic addition reaction, if you see, the majority of the reactions of alkenes will be the same type of the mechanism with a slight modifications this side, that side. The benzene, one example for the electrophilic substitution, if you study, the majority of the reactions of benzene follow the same mechanism with a slight variation in the attacking species or outgoing, slight variation, but major reaction will be the same type of the reaction. So all the 7 reactions, specifically here 3 types, here 3 types. If you read all these mechanisms with internal, the how this influencing taking place, how the molecule undergoes the inversion, all such internal the stereochemistry involving the reactions, if you read, the most of the organic reactions we can do in a justified manner understanding.